Okay, I'm going to share my screen. Excuse me. Okay, this is what we're going to talk about on Mystery Science. It's called What Would Happen If You Drank a Glass of Acid. It's very interesting. Let's make this go away. And then I'm going to make it full screen, hopefully. Okay. Doop, doop, doop. Oh, or that. See waiting room. Let's just wait. Pooja, sorry. Okay. Well, my top screen up here doesn't seem to want to go away. So that's annoying, but whatever. Okay. Well, then we're gonna go ahead and just get started, and I'll wait for that to go away. Okay, I'm gonna just exit that because I'm annoyed now. What? Try one more time. There we go. Do full screen. I don't like this thing up here. I wish it would not be up here. Oh, I guess I can move it down to here. Cool. I'll have to do that next time then. Okay. Okay. All right, guys. I'm gonna get started. Pooja is trying to get in, but I don't really need her to be in right now. So, Chantel, it says that you are here, but I can't mute you for some reason. So I don't know what that's about. Okay, anyways, sorry. Just wasting time. My bad. All right, guys, question 1. Eli enjoys feeding the squirrels in his backyard. He notices that they spend a lot of time collecting seeds and nuts. He wonders about what factors affect which foods squirrels choose to collect. So he decides to design an experiment. He has the following supplies. All right. Oh, sorry, I forgot to read the title. We're identifying questions that are investigated with materials. Okay. So we're going to look at a list of materials and figure out what we can answer with those supplies. Okay. So 2 identical squirrel feeders, a bag of sunflower seeds, a bag of walnuts, and a tree to hang the feeders from. Using only these supplies, which question can Eli investigate? Can he figure out which type of tree do the squirrels feed from most often? Do the squirrels select sunflower seeds or walnuts more often? Or do the squirrels eat walnuts from large feeders more than small feeders? See if I can. Okay. Does anybody have any ideas? Anybody have any ideas? Okay. So as a reminder, each question is going to give us supplies to do an experiment, quote unquote. This experiment gives us 2 squirrel feeders, a bag of sunflower seeds, a bag of walnuts, and then a tree to hang them from. With these 4 supplies, which one of these questions can we answer? The type of tree, a large feeder versus small feeders, or sunflower seeds or walnuts? Anybody? Deshaun.
Yeah. So which one out of them 3?
Yep, which one out of these 3 can we answer?
The middle one?
The middle one? All right. Let's see if he is right. Yes, good job, Deshaun. Yeah, guys, out of the supplies we have, it didn't tell us about the size of a squirrel feeder. And then it didn't talk about trees and differences in those either. So the only difference would be difference between peanuts and walnuts. Or sorry, sunflower seeds and walnuts. All right. So same thing from these supplies. After Tanner cleans up a spill, he hangs a wet cloth towel in the laundry room. 2 hours later, he notices the towel has partially dried. He wonders what factors could affect how cloth dries. So he decides to design an experiment. 2 identical white cloth towels, water, a clothesline in the laundry room, a clothesline in the backyard. So with these supplies, which one can we answer? When hung in the laundry room, do black cloth towels or white cloth towels dry quickly? Does a small cloth towel or a large cloth towel dry faster in the backyard? Or do cloth towels dry faster if they're hung in the laundry room or the backyard? Simbriti.
I think it's the last one.
Right? She is correct. Based on what we have, it wants to know the difference, or we can figure out the difference between the laundry room and the backyard. We got 2 identical white cloths. We don't have a black cloth, so it can't be that one. All right. And then it doesn't say that we have 2 different sized cloths. So the small and large one, we can't do that one either. So good job, somebody. Boom. All right, next one. Maureen likes to skip rocks at the river. She notices some rocks she throws skips off the surface of the water many times, while others skip once then sink. She wonders what factors affect how well rocks skip on the water. So she designs an experiment. She has 10 small flat rocks, 10 large flat rocks, and then access to the river by her school. So, which one can we answer? Do rocks skip more times when thrown across the river or across a pond? Do round rocks or flat rocks skip more times when thrown across the river? Do small rocks or large rocks skip more times when thrown across the river? I would like someone other than Deshaun and Sambriti to answer. Remember, as long as you answer once today, then you don't have to answer anymore, and then it's free game for everyone. So just keep that in mind. The sooner you answer, the quicker you don't have to answer anymore if you don't want to. So does anybody think they can help me out here other than Sambriti or Deshaun figure out which question we can answer? Make sure we raise our hand. All right. Daisy, thank you for raising your hand. Which one do you think we can do?
I think it's the last one.
Think it's the last one? Perfect. Guys, Daisy is correct. It is the last one. It talks right here. It gives us small rocks and large rocks. It doesn't say we have access to a pond, so we can't do that one. And then it doesn't say anything about round rocks, so it can't be that one. So good job. It is the last one. All right. Next one. Judith leaves some chocolates in her jacket pocket. When she finds the chocolates later, she notices some of them have melted. She wonders what factors affect how quickly chocolate melts, so she designs an experiment. She has a bar of milk chocolate, a bar of dark chocolate, a stove, and a pot. With these supplies, which one can we answer? Does dark chocolate or white chocolate melt faster when heated on the stove? Does milk chocolate melt faster when heated in a microwave or a stove? Does milk chocolate or dark chocolate melt faster when heated on the stove? Right? And again, if you haven't participated, I want to call on those ones first. And then once you've participated, you technically don't have to anymore if you don't want to. I just need to know that you participate at least once. Demetrius, which one?
The last one.
Yes, good job, buddy. Yeah, the first one, guys, it does not talk about white chocolate. We have milk chocolate and dark chocolate, but not white chocolate. And then in this one, it talks about a microwave. We don't have a microwave in our experiment. We just have a stove. So Demetrius is right. It wants us to know about milk chocolate, dark chocolate, and then on a stove. So good job. All right. All right, next one. Okay, we're doing the same thing, it seems. We are given we're given a list of supplies, and then based on just the supplies, we're trying to figure out what question we can actually answer. Okay, so Shelby is sledding with her friends. She notices that some of them go faster down the sledding hill. She wonders what factors affect sledding speed, so she decides to design an experiment. She has the following supplies available: access to a small snow-covered hill at a park, a small plastic sled, a large plastic sled, a rubber inner tube sled, and a stopwatch. With these, which one can we answer? Okay. Does a rubber inner tube sled or a plastic sled go down the hill faster? Does a plastic sled or a wooden sled go down the hill faster? Does a rubber inner tube sled go faster down the small hill or down a big hill? Right? And again, I would like to see a participation from someone that hasn't gone yet. So I have Chantel, Siwan, Reham. I haven't heard from you three yet. So if one of you three could help us out. Reham, which question can we answer? Oh, just type it. The first one. Reham is correct. All right. So guys, we have a rubber inner tube sled and a plastic sled. If you look, if you see, so we can do that one. This second one, it talks about a wooden sled. We don't have a wooden sled, so we can't do that one. And then the last one talks about a small hill and a big hill, and it does not tell us about two hills. It only says we have access to a small hill at the park. Just one hill, not two. Okay, so Reham, good job. All right, next one. Shivani notices that her cell phone charges quickly sometimes and more slowly other times. She wonders what factors affect how quickly a phone charges. So she does an experiment with, she has one cell phone, a 2-foot long charging cable, a 5-foot long charging cable, a stopwatch, and a wall outlet, right? So with these, can we answer, does a cell phone charge faster when plugged into the wall outlet or a computer? Does a cell phone charge more quickly when it's turned on or when it's turned off? Does a tablet charge faster with 2-foot long charging cable or a 5-foot long charging cable? All right. Again, I would like to, oh, perfect. Siwan.
I think it's the one in the middle.
Think it's the one in the middle?
Yeah.
Okay. So the one in the middle says, does a cell phone charge more quickly when turned on or when it's turned off? And let's see. Does it charge quickly sometimes, more slow than others? Da, 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 da. So, nowhere actually in our experiment does it talk about the phone being on or off. So
Yeah.
I don't think that that's what they are trying to test here.
But
Um,
the
would you,
the other one, like, no, there's nothing that it says in the other ones too. So, like in the last one, they're talking about a tablet, and like in the story, there's no tablet.
you're right. So
And
does a tablet charge faster? Doesn't talk about that one. And does a cell phone charge faster when plugged into the wall outlet or computer? So guys, this one's tough. Yeah, it doesn't talk about a computer, but it also doesn't talk about a tablet. So based on these, C1's probably correct. Does a cell phone charge quickly when turned on or when it's turned off? That's really the only one it looks like we can test. So, is he right? He is right. Good job, Siwan. You did really good, buddy. Yeah, nice. All right, guys. Bruce is washing dishes after cooking his dinner. He notices that some of the dishes still feel oily after being washed. He wonders what factors affect how clean dishes are after they are washed. So he designs an experiment. He has a sponge, liquid dish detergent, a bar of soap, hot water, cold water, and a pile of dirty dishes. All right? With just these, what can we answer? Are dishes cleaner when washed with liquid dish detergent or with bar soap? Are dishes cleaner when washed with a soapy sponge or with a soapy rag? Are dishes washed in a dishwasher cleaner than dishes washed by hand? All right. So it wants to know which one. Chantel, which one do you think?
I think is the second one.
I think it's the second one.
Yes.
All right. It talks about dishes being cleaner with a soapy sponge. We have a sponge and we have soap. We have two kinds of soap. So far it's right. Or with a soapy rag. So we have our soap, but do we have a rag?
Let me see. No.
We don't have a rag, so we probably can't do that one. So would it be the first one or the last one?
I will probably think it's the first one.
Yes, good job. Yeah, because from here, it talks about wash with dish detergent or bar of soap. We have both of those. But in the last one, it talks about a dishwasher, and it does not say we have a dishwasher, so we can't do that one. Right, good job. All right, guys.
Hey.
Yeah, good job. All right, guys, we are officially, everyone has participated at least once. So um, the remaining 3 questions are free grabs to anybody. All right, and um, it looks like we're going to be able to answer multiple questions, so not just one. Yeah, like this one says, which 2 questions can we do? All right, okie doke. So Kirk puts a few pears in a bowl with some fruit. A few days later, he notices that some of the pears are soft and ripe, while others are hard and unripe. He wonders what factors affect how quickly fruit becomes ripe. His experiment gives him 2 unripe bananas, 2 unripe pears, a glass bowl, and 2 paper bags. Which 2 questions can we answer? Do pears become ripe more quickly when stored in a glass bowl or a paper bag? Do apples or bananas ripen more quickly? Do pears stored in a glass bowl ripen more quickly than pears stored in a metal bowl? Does a pear become ripe more quickly when stored in a paper bag by itself or in a paper bag with a banana? Interesting. Interesting. All right. I see a lot of hands. Whoa. Reham, what do you think? Reham? Oh, sorry, chat box. I'm coming. The first one, okay. Do pears become more ripe when stored in a glass bowl or paper bag? Okay. And then we got to pick one more. Reham, do you want to pick the other one, or do you want me to ask some Breedy maybe? Because I see her hand up too. Let me check. Ask someone else. Okay, so Brady, what's the other one?
I think it's I can't be sure, but the last one.
The last one?
No! Oh my gosh, I'm so scared.
Don't be scared. So guys, this one's kind of tough. The only one I can tell you guys immediately that we can't do is the metal bowl, because we don't have a metal bowl. So we can't do that one. So I'm glad no one chose that. That's good.
The second one.
The second one?
Yes.
Yeah.
Yeah, the second one.
Okay, we've selected 3. Okay, we only need to select 2. Let's find out which one we didn't need. So,
I feel so horrible.
Sombriti, don't feel horrible. You were right the first time. Sombriti, what I've learned with you in science, don't ask unless you know the answer. Sorry. God. Sombriti, you were right. So you should trust your gut, because usually in
I was.
No, you're fine. Usually in science, you do really good. Okay? If we paid very close attention to the second one, it talks about apples. We don't have apples.
Oh my gosh, I'm such an.
Nope. No, you're not. You were right the first time, remember? So just don't doubt yourself is the lesson we're learning today. Okay? Because you are really good at science, Brady. Like really good. Okay? So do not worry. All right. Rob wants a bouquet of flowers to stay fresh as long as possible. He notices some of the flowers in the bouquet stay fresh longer than others. He wonders what factors affect how long flowers stay fresh in a vase before they begin to droop. So he decides to design an experiment. He has the following supplies available. He has 5 tulips, 5 roses, 2 identical vases, 1 packet of powdered flour, food, and water. Using only these, which 2 questions can we do? Do tulips stay fresh longer when kept in water with powdered flour food? Do tulips or roses stay fresh longer when placed in a vase of water? Do tulips or poppies stay fresh longer when placed in a vase? Do roses stay fresh longer when placed in a large or a small vase? Ooh, sorry. All right. I see, Chantel, I see your hand up. Is your hand up from the last question or this one?
The last question.
Oh, okay. Do you want to try this one?
Sure.
Okay. So, all you have to do, Chantel, is tell me if you think it's one of these, or maybe you can even tell me which one it's not.
I think the last one is not.
You are correct. Yep, it's not that one because it says large and small. In this, our supplies are identical vases, so it's not the last one. Good job. Okay, so Reham, what do you think? Oh, there we go. Can I say both? Yes, you can. The first and third one. So we have the first and the third one. All right. So let's just double check before we move on. Do tulips stay fresher longer kept in water with powdered flour food? We have tulips and we have powdered flour food. No, wait. Okay, we're waiting. Dun, dun. The second one and the first one. Yes, good job, Reham. Yeah, because the third one talks about poppies. We don't have those flowers. So good job. Boom. All right. Barry, drinks coffee with milk every morning. Same. He notices that some mornings his coffee seems to cool down quickly, and some mornings it seems to stay warm for longer. He wonders what factors affect how quickly his coffee cools down. So he decides to design an experiment. He has 2 small coffee mugs, 2 large coffee mugs, hot caffeinated coffee, a pot, a stove, cold milk, thermometer. Right? Which 2 can we answer? Does a small mug of coffee stay warm longer than a large one? Does a large mug of caffeinated coffee cool down more quickly than a large mug of decaf coffee? Does a small mug of coffee cool down more quickly if it is sweetened with sugar or unsweet? And does a small mug of coffee stay warm longer than warm milk is added instead of cold milk? Whoa, that's a lot. Okay, someone said something. Hey, Chantel. All right, does anybody want to maybe guess what it, does anybody want to guess one of the ones that it is, or maybe one of the ones that it's not? Reham, is your hand up, or is your hand up from the last one? Remember, let's make sure we use the group chat for math and science. Okay. Okay, so Reham put her hand out, that's fine. All right, guys, just real quick. That's okay, Daisy. Thank you for apologizing. You're fine. Okay. So guys, let's pay close attention to what we have. We have small cups, we have large cups, we have hot coffee, we have a pot, we have a stove, we have cold milk, and a thermometer. Okay. So the first one. Oh, C1 raised his hand. C1, what do you want to help us do? The ones it's not, or the one that it is?
Just not.
Okay, so what is it not?
Does a small mug of coffee cool down more quickly if it is sweetened with sugar?
Yeah, so guys, C1 is right. It's not the sugar one. Oh, sorry. It's not the sugar one because we don't have sugar in our experiment. So he's right. It's not that one. Okay? So we can cross that one off. Not this one. Okay? That one. Oh, can't be that one. So, got 2 options left. We have a small mug of coffee warm longer than a large one. Okay? We have small and large mugs. Does a large mug cool down of caffeine cool down faster than decaf? We do have a large mug and we do have caffeinated coffee, but do we have decaffeinated coffee? I don't know. Does a small mug of coffee stay warm longer than warm milk instead of cold? We have cold milk, but do we have warm milk? So guys, this one does sound a little bit challenging, but let's think of what the supplies that we have. Yes, we have cold milk. We don't have warm milk at the start, but we have a pot and we have a stove, which means we can make warm milk, but we cannot make decaf coffee. You would have to change the molecular structure of the coffee to turn it decaf, which is impossible to do unless you're a really talented scientist. So the only ones it can be is the last one and the first one. Oh, well, let me click. Nope, it won't let me click. There we go. So does that make sense, guys? We just, all we had to do was pay really close attention to what supplies we had. Thank you, Demetrius. Because a lot of us weren't raising our hand, but that's good because you guys were thinking, and I'm proud of you for that. Because you all knew we didn't have warm milk, but you also knew we didn't have decaf coffee. So that one was tough, but all we had to do was check our supplies again. We couldn't make decaf coffee. There's no way we could do that. But you can warm up the milk with the pot and the stove. So erase that, and then we're gonna move on. Boom. All right. I think this is the last one, right? Yep, this is the last one. Cool. Ooh. Okay. Colette puts a bottle of lemonade in the freezer. When she removes the lemonade, she notices that it has started to freeze. She wonders what factors affect how quickly a liquid freezes. So she decides to do an experiment. She does an experiment using water, lemonade, two 12-ounce bottles, a 12-ounce ice cube tray, a freezer, and a stopwatch. So can we figure out will 12 ounces of water in a bottle and 12 ounces of water in a bag both freeze if left in the freezer? Will 12 ounces of fresh water and 12 ounces of salt water freeze if left in a bottle overnight? Will 12 ounces of lemonade and 12 ounces of water both freeze if left in a bottle in the freezer for an hour? Or will 12 ounces of water freeze more quickly in an ice cube tray or in a bottle? Right? So, based on what we have, what could they be or not be reham? What could they be or not be? I think the answers are the last two. All right. Reham thinks they're the last two. Oh my gosh. It won't let me click. Come on. There we go. Cool. So guys, I'm going to just check if she's right based on these two. Let's see if those ones are wrong. So it talks about 12 ounces of water in a bottle in a bag. If you look here, nowhere does it talk about a bag. We have an ice cube tray in a bottle, but no bag, so it can't be that one. And then here it talks about fresh water and salt water. Here it just says water. It doesn't tell us if it's fresh or salt, so we wouldn't know that. So Reham, you are correct. Boom. All right, guys, we did it. Go us. Awesome. Cool. So I'm gonna take us to this website called Mystery Science real quick, just to like show you. Yay indeed. So guys, this website, another reason why I'm not requiring it is it looks like it only goes from kindergarten to 5th grade. It might go to 6th grade, but I might have to pay for it, and I have to ask Principal Ben if I'm allowed to buy it. But this website's pretty fun. Just Mystery Science. You watch a video like on Edpuzzle, and then after the video, it helps you do an experiment. So when it's over, it will, maybe not this one, but usually. And then you can always view hands-on activities, which these will be things that you can like do for real. And then it'll always say activity prep right here at the bottom of a video if you're able to do it. And then it tells you what you need. So like this, 8 sheets of blank paper, you'll need paper towels, crayons, a pitcher of water, plastic cups, and index cards. Okay, so if you guys have any of those like at your house, then you're more than welcome to hit play and then do a science experiment. Okay, so I just wanted to introduce you guys to this website because I know, like on iExcel, I know it's not like the most fun science. It's a lot of, just questions and stuff. But on this website, it lets you just straight up do experiments. The only issue, like what I've been saying, is you do need supplies. All right. So anytime you click on a video, that you find interesting, you'll just go to activity prep, and then it tells you, like this one, for example, doesn't need supplies. Just make sure you have enough just make sure students have enough space to move around as they pretend to be like different animals. So that one, and as you can see, that one's a kindergarten level one, so you guys probably wouldn't like that one anyways. But yeah, it's a really neat website, guys. I highly recommend looking at it. Oh, I literally clicked on kindergarten. My bad. For you guys, maybe do some of the 5th or 4th grade ones, just because they're hands-on and they're fun. But again, I'm not gonna grade them. I might post some of them. I might post some of them to our Google Classroom, but I'm not grading them. I won't require them, though. There won't be a due date. I just want you guys to have more fun, basically, especially since we'll be Zooming the rest of the year online. The tough part about science and art, which is why I'm teaching math and science and not art, is just you need supplies. And since I can't, you know, buy everyone a sketchbook and pencils and paint and clay and markers and crayons, you know what I mean? That's why I can't do art, but that's also why science is a little tough, because I can't just go out and buy all them and then like mail them to your house, and you know what I mean? But the website's called mysteryscience.com. It's free right now. They're very nice because of everything going on in the world. They're going to give it to us for free. I've already signed up too. I think I can add you guys. If it does make you sign up, you should be able to sign up with your school email. But yeah, if you find one that you like and you have the supplies, I'd give it a shot, just so you can still have fun with science at home. But yeah, that's all I have. So let me go ahead and end the recording.